as you increase the SID, you have less photons hitting the area, so you are decreasing the density, which decrease contrast. Now, if you look over there on that chart, what does it say for SID? Nothing. Yeah, okay. But, just saying, okay, you know, so if in reality, if you double your distance, okay, so we're at 36 and we go to 72, we double our distance, right? What happens to the intensity at the film?
Goes down.
By how much?
Half.
Yeah, 4 times.
By a factor of 4, which means it's reduced by 75%. Okay? So we have now a quarter of intensity. So now that image is totally underexposed, so it's going to have a decreased contrast, right? Okay. So, but in reality,
This
okay.
is another one
But
where
on the
generally
test.
speaking.
On the test.
On the chart, on the test.
On the chart, on the test, SID does nothing to the contrast.
Nothing. Contrast.
It does something to the density, which means it makes it totally underexposed, which we said is a decreased contrast. Or if we're cutting our SID in half, we're going to get 4 times the amount of radiation, which means it will be grossly overexposed, which means that it decreases the contrast. So we're dealing with the ends again, okay? But in general, if we increase or decrease our distance a couple inches, it's not going to change our contrast, okay? All right. We just mass. There is too much or too little density, then there is a decrease in contrast.
Bless you.
Bless you. Remember, when we do our whole scale of acceptable and non-acceptable images. Okay. What did we say this end? These are overexposed up here, and they're a decreased contrast. Okay, so they're a longer scale of contrast then, okay? But whether it's overexposed or underexposed, and this is sometimes where students don't get that because they learn this chart first, you have a decreased contrast. So if it's too white or too, it's just blah, you just have lots of shades of whiteness, okay? So it's a long scale, so it's a decreased contrast.
So I understand that if it's grossly over or underexposed, there's decreased contrast.
Uh-huh.
In general,
Mm-hmm.
mass doesn't affect contrast, or at least that's what we were taught by
Correct.
Chris. Like there's a 0 up there.
Right,
So except for the extremes.
except for the extremes.
there's not really any effect.
No,
Okay.
not at all. No, we can't say, if we use a lot of mass, we're going to have a long scale contrast. That doesn't
Okay.
happen unless it's a body part that ends up being overexposed.
Okay.
Okay, so another contrast test. More what?
More vertical.
More vertical, you got it. Okay, so it's going to go up steep, okay? And a 90 kVp image will be more horizontal, okay? Now, what does that tell us about the latitude of the image?
That much less latitude.
What'd you say? Here it's going to be a
Less latitude.
less latitude or a narrow, okay? Because if we drop the line from here to there, it's going to be really short in there, okay? But if we drop the line from here and there, that's going to be a wide latitude, okay? which one will give us more margin of error? Increase margin of error. Decrease. Okay, I got it? So that's the big difference between a 60 and a 90 kVp beam. You got it all? If you can, want to come up here and take it, you're better.
No,
And a 90 kVp beam. What is the photon going to look like as it moves through the air if it's a 60 kVp beam? Short wavelength?
Medium.
long wavelength.
Longer than the 90.
Okay.
Longer because it's slower.
Okay, and the 90's gonna go zipping along, right? Okay, we got that, all right. So, what's gonna happen to this as it hits the body?
It's gonna go through slower.
It's
Or
gonna
it's
get
gonna be
stuck
Lose
in there,
energy and it's gonna get what?
absorbed.
Absorbed. And this is gonna go, what happens when it gets through there?
It still slows down a little bit.
Some of it's gonna go absorbed, but some of it's gonna go through, right?
How about scattering?
Yeah.
Okay.
That's good.
And what kind of scattering is that called?
Compton.
Compton. And what's this kind of absorption called?
Electric.
Yes. Okay, good. All right, so we got this. And what did we say that this does to the contrast?
That gives more contrast.
More contrast, so it increases contrast, which means there's a greater difference
Difference. Right.
between.
The densities.
So it'll be high subject
Right.
contrast.
Yeah, so it'll be high subject contrast, and that's because there's a big difference, okay? And it's gonna be what? What else do we call it? Short
Scale.
scale. Because why?
Because there's a big difference in the densities.
Not a lot of gray.
Okay, because there's few densities.
Well, it could.
We're gonna call it short.
Right.
Because it doesn't have a lot of them, but it's a high contrast because there's a big difference
Right.
between adjacent shades.
Right.
Okay? Where with the 90 kVp, we're gonna have your film with the contrast. I think we did, yeah, we went over that. Did we talk about subject contrast? Maybe not, okay? We did when we talked about density, and what I'm going to say is no different from that, is the subject contrast and the fact that the body has different tissues in it with different absorption levels gives us radiographic contrast. Somebody's going to do an experiment of a tub of water. Okay, what's going to happen? What kind of density will it have? How many densities will it have? Let's put it that way.
Two.
Or
The
two.
tub.
The tub
And water.
and the water. Yeah, and that's it, because both have different absorption levels, okay? So, you know, the fact that the body does have different tissues gives us radiographic contrast, but it all starts with the body, okay? And depending on what part we're imaging and matched with our technical factors may show a different level of subject contrast than another area, okay? So we have to worry about the thickness and the opacity of the tissues. You know that from before, okay? Amount of tissue is the thickness. We have to measure to determine that, so calipers are always important, okay? I think there was a question about what happens to a fiberglass cast on a rewrite or an x-ray of a fractured part, and what does it do?
So yeah, could you talk about that? Because I don't know.
Okay, fiberglass is nothing but little glass particles suspended in a matrix, okay, and filled in on a web type of material, okay.